description of a polynomial?
That's what I was wondering.
What's the highest n can be?
Infinity.
What's the highest n can be? Yeah. Can't you have a 1,000-degree polynomial?
Yes.
Holy cow.
I mean, it would be an awful polynomial, but couldn't you have x to the 1,000th power? Sure, why not? X to the 1,000,000th power. X to the 7th power. So could I give you a finite? What's that? A finite number of terms? No, because the higher the degree of x, the more possible terms, or the more possibilities of the number of terms that we could have. Does that make sense? So I had to generalize. Now, real quick, n in this description stands for what again? True, it is a non-negative number. What's another way of describing that, though? For what it means,
A natural number?
right there. The x power, but isn't that an x power, and that an x power, and that, and that? Yeah, but these are all powers of x. X to the 1, x to the 2, x to the 0, which is just a constant. Who's n? Number, it could go, like, it could keep expanding and be higher and higher.
Natural numbers that are greater than 1.
No.
Because you cannot have 0 and
Well, yeah. Those are the options, but what word could describe n himself? Not all of his options, but who he is for or to the polynomial. Yeah, he's a power. Which power? But they're all powers of x. Which power of x is n? Going deep. As soon as I say this, you're going to know it, though. No? Well, I mean, it is a real number, that's true. But they're all real powers. 1, 2. What's so special about n?
first letter of the word.
No. Determines how big? I like it. We're getting closer. What do you mean determines how big? Determines
You can make us feel really
how big?
Bonus.
Okay.
See?
0 is the lowest power of x. Who is n?
Oh, the highest power of x. Ah.
Right? He's the top guy. He's the highest power, whoever he is. Now, what's so special about the highest power? Do you remember the special name that's given to the highest power? I've already said it like 4 times today. Nope. Nope.
Oh, X.
It's a brand name of a deodorant. It's showing on my thermostat right now. There we go. The degree. Oh, I didn't hear it. The degree
I guess he gets credit.
of the polynomial. The degree of the polynomial. So if n is 1,000, 1,000 is the degree of the polynomial. It's the highest possible power in the polynomial. Because once there's a particular polynomial given to you, it's been set. It's not infinite because it's been set. Now, what's the title of this section? Not polynomials. That's kind of like half the title of the entire chapter. What's the title of this section?
Models.
Why are we talking about quadratics?
Because they have something to do with degrees.
Because last section or last chapter, we already talked about the lowest possible degree. What's the lowest possible degree of a polynomial?
0.
X to the 0, which would be a constant, and y equals a constant looks like what? A horizontal line, right? Y equals 2 is going to be a horizontal line at 2. Y equals -1, a horizontal line at -1, etc. But wait a minute, what's the next polynomial that we could cover? There's the constant function, horizontal line. What's the next one? Linear, y equals mx plus b. Have we already talked about that like 2 different sections? Yeah, so we're done with that. So now we're on to what's the next highest or higher degree? Degree of 2, hence a quadratic. Quadratic. Definition, technically, according to our book, I don't know if it's really the greatest of definitions, but it says the following defines a quadratic function and to some degree. That's funny. It's right. Nah. Now, what have we used or what have we done with quadratics in this form before? Someone tell me something. What have we done with quadratics in this form? We factored. That's one way. One application is factoring. When do we factor? Usually when we're finding zeros of a function, right? Zeros, aka who? The x-intercepts, right? So
Did you write that? Useful form?
no, I wish I did.
Oh.
If I was Joyce Lee,
That
maybe,
looked
but I'm
good.
not. What else have we done with this form? How else have we found zeros? Huh? Yeah, we graphed these before. Looking for something a little bit more particular though. F of G, I would plug stuff in. I'm trying to think something else particular to the quadratic function.
Symmetry?
Set it equal to 0, and we could factor to solve, or sometimes factoring fails, right? Either our factoring fails, or the factoring fails us, and it's impossible to be done. Yeah, that's coming. Hold on. But what else? What else besides complete the square? Yeah, that's what I was looking for. Thank you. And the quadratic formula, right? Good place to review it, since we're talking about quadratics. The quadratic formula also used to find zeros, right? X-intercepts. And what's that formula, just so that we have it, just in case we need it?
X equals plus or minus b.
No.
This
X equals negative b plus or minus square root b squared minus 4ac all over
2a.
There is a plus minus, but it's after the negative b. Maybe some of us need to learn that one. Relearn it, remember it, I don't know. However, this quadratic formula happens to come from completing the squares. We're going to talk about that in a second. Let's get back to the characteristics of a quadratic, though. What degree does every quadratic have to have? It's a degree of 2, so we could say n is equal to 2. That's the highest power, right? Standard form. Now, technically, I'm not exactly sure your background in math as far as what textbooks you've used, etc., whether you came or here the whole way or not. One way of describing this is vertex form. That's my handwriting, not as nice as theirs. Vertex form. And we'll talk about why it's called vertex form in just a second. But standard form. From here on out, it needs to be the standard because it is the most useful form. Now, that doesn't mean that the other form isn't useful. It's useful, but this is the most useful form. And you'll hopefully be able to tell me why in just a moment, in just a second. We can go ahead and expand this just a little bit. 1 equals a times x minus h quantity squared plus k. What should this remind you of if there's an h and a k? The circle formula, right? What did h and k stand for with the circle?
the center.
The center. Think about a quadratic. All quadratics have the shape of a... What would be the most important point of a parabola? The focus. No. The directrix. Uh-oh. That was last year. Sometimes the origin, if it's a normal parent function x squared, but it could be somewhere else, and the general name, I think some of you have already said it, is the... Right, and the minimum and maximum happens at the vertex, right? The vertex. So let's go ahead and, now that we've figured out the vertex, let's talk about him. The vertex is, can be denoted HK. And if we are able to get a quadratic into its standard form or vertex form, oh hey, because you can see the vertex, we can just pull it out of there. However, there is a shortcut. There is a cheater step. I'm not exactly sure if it's a shortcut. It is something extra to memorize, so some of you are like, yeah, no, peace out, I'm not going to do that. But if you want, we can always solve for the h of the vertex with negative b all over 2a without the rest of the stuff. The whole quadratic formula solves for zeros. This solves for negative b, I don't think. I could take the definition x squared plus bx plus c, and I could plug in and find h using this little baby formula. And if I can find h, question, what else can I find? How can I find k? Because I'm given an equation, and how can I find a y value with an x value? Plug it in, plug it in.
We're seriously getting
Okay. So there is a shortcut for finding the vertex, but that does not mean that it is completely useless to practice how to get this form on our own without using a little cheater shortcut that we can memorize. Because sometimes, to be honest, this cheater shortcut's harder than just figuring this out. However, to find vertex form, we have to take a general quadratic and make it some version, some transformed version of a perfect square binomial.
So we're getting the right side of the standard form and considering it f of h, even though we don't have x or the a.
If we have this form,
Okay.
we can skip all of this and take the a and take the b and find h, and then plug it in to find
We
k.
have the,
Does that make
okay,
sense?
yeah.
But to get this form, what do we need? To complete the square. Because the general definition of a quadratic ax squared plus bx plus c, do you see a perfect square binomial? Maybe. It depends on how you, right? But not every quadratic factors to be a perfect square, so what do we sometimes have to do? Make it that way. Now let me show you one quick application of completing the square before we go over the general steps. We'll come back. One quick application. You ready? You're in honors. Here we go. To complete the square, I'm going to walk through one completing the square problem with a general quadratic. I'm not even going to put numbers in. I'm not good. You ready? The very first step of completing the square is look at your standard form. Is a allowed to stay next to the x? Isn't he factored out? A times parentheses x minus h. The very first step is to take out a. When we take out a from x squared, he's by himself, which is a good first step. When we take out a from b, what's factoring? What operation do you remember? Dividing. So we could say whoever b is, just divide him by a. Okay. Completing the square says it's not what I want yet, but I'm going to make it what I want. But when I add something here, the only way to keep an equation balanced is if you add something to one side, add it to the, or if you add something to one side, subtract it somewhere else on the same side, and it ends up basically acting like 0. Now, what would I put in that spot? To make this a perfect square, I'm going to go ahead and take whoever is on the inside, and I'm going to cut that term in half. I'm going to cut that term in half. And when I cut that term in half, I'm going to figure out what number should have been squared to make that final piece. Because a perfect square, you double the outer and the inner to get the middle term, and then you square the last. So I'm going to take 1/2, which is just going to be b over 2a. That looks familiar. And then I'm going to go ahead and square it. And I end up with but what I put in one place, where else do I have to put it? I have to also put it out here.
But that is being
However,
foiled
is this the same thing?
no, because there's the a foil in
Oh, there's an A on the outside. So I have to go ahead and bring that A in and say, uh-oh, it's this whole thing times A. and times a, maybe I should simplify to make it a little bit prettier. I have b squared. B squared, this isn't killing a puppy, there's no addition or subtraction, I'm just doing b over 2a times b over 2a. It'd be 4a squared, but what happens when an a comes in? Cancels out the second a. So I just have this, and you're like, this is gross. Hold on. Now what do we do? This whole mess, all of this confusion, is able to now be factored as x plus b over 2a. X plus b over 2a plus c minus b squared all over 4a. And you're like, this is disgusting. Hold on.
Yeah.
And the reason why it's able to simplify down is because I can take this polynomial, I've made it a perfect square. I've made it a perfect square. And then I'm ready to go. Now technically, you could memorize this and always get to completing the square from this. That's one way. You could memorize it and be like, But you could always take the a and the b and the c and you could plug into this formula and it'll always work. But does that sound very fun?
No.
For most of you, no. You'd rather have the process down so you don't have to memorize all this yuckiness in this step. Now, why am I showing you this? Well, number one, to say, hey, there is a way to memorize how to complete the square without understanding and just being able to apply a general process. However, isn't there a particular application of this form called the quadratic formula, and the quadratic formula solves for what? The zeros. Doesn't it solve for the zeros? The x-intercepts, right? How could you solve for the zeros from this mess?
Oh, you just send the c.
You have to move all this stuff over, right?
Yeah.
You have to get x alone. So then we would go ahead and, let's see, we would add the b squared over 4a. We would subtract the c. Then how would we solve? Divide by a next, which is the same thing as multiplying by 1 over a, the entire thing. Then we would end up with b squared over 4a squared minus c over a. Ugh. Now what? Do you see the plus or minus square root? But how bad is it going to be square rooting this
Pretty
thing?
bad.
Pretty bad. Unless maybe we got a common denominator. What would we multiply? Let's make this into a pretty single fraction. Right now it's double fractions. How would we make the denominators match? Multiply by 4a over 4a. Then we would end up with b squared minus, my common denominator is 4a squared. B squared minus, this looks familiar.
I'm learning to.
Now what do we do?
Multiple sides before.
No, because it's same top and bottom, Brandon. It's like multiplying by 1 creatively. If I multiply something by 5 over 5, it's really times 1. That's why it's allowed. I have to plus or minus square root both sides, right? Plus or minus square root,
But the
plus
balance
or
gonna be
minus
2a.
square root. Shh, giving it away. So that'll be plus or minus square root of b squared minus 4ac all over square root of 4a squared is 2a.
I'm learning to endure the times that I'm lost because I know in the end there will be a good result and I'm gonna be in awe.
Now, how do we get x alone? Okay, hold on a second.
Christy.
So that's negative b all over 2a plus or minus square root of b squared minus 4ac all over 2.
I'm gonna come back to the class across the hallway to Algebra 1B because those were good times.
Those were good times. What did I just do? Okay, when I taught Algebra 1, I showed them this, and they were completely dead and lost, and then I said, never mind, just memorize it. Okay, so, and that's probably what your teacher did once, too.
Yep.
Who is this? Common denominators. Negative b plus or minus square root b squared minus 4ac all over 2. What did I just do? Showed you how someone once came up with the quadratic formula. But where
What, Amanda? Oh,
did
Amanda
the
wants to redo it.
quadratic formula come from? Completing the. So who came first? The quadratic formula or completing the square? Completing the square.
Amanda just told me she wants to go on the board and do it again.
So some people in some countries never learn this because it's really just a derivation of completing the square. So they're like, forget it. Let's just learn completing the square and never have to memorize this extra weirdness. Anyway, all that to say, this is useful. You can memorize, or you can just really learn how to complete the square. Now, hold on. Hold on. What do we start with? Like the definition of a quadratic, the normal form, right? Normal as in not perpendicular. People in physics, you should learn. So, maybe you haven't learned it yet. This is the normal form. Who is this? The standard form, where you can see the vertex. What's the very first step to completing the square? Get a leading coefficient of 1, but there's an get a leading coefficient of 1, but there might be an a. What do we have to do? Pull him out, like you saw on the page before. We always pull a away if he's not 1. Pull a away, remember that. If he's not 1, factor out a from x squared in the x terms. Who did I not pull a away from? The constant. Because if he's not a perfect square already, well, he's not exactly where I need him to be. Then I form a perfect square by adding by 0 creatively. How did I do that? You can either add to both sides, but what did I do? I added and subtracted from the same side. Why? I want everything over here at the end anyway. So I don't want to go putting stuff on the other side if I'm just going to move it back over soon. So technically what I'm going to choose is the second one. But you can do the first one if you're more creative, more comfortable with it. And technically, what am I going to use every time? I'm going to use 1/2, whatever is left by the x term after factoring out a and then squaring it. And then last but not least, factor and simplify into my vertex form. Now, let me give you a few seconds. That is my quick recap from when I first taught completing the square in Algebra 1. I kind of just threw it all on the page. You guys have seen it before. You've done it before, but I'm not sure if you have it mastered. Especially since quite a few of us, the basics are kind of hard. Maybe even the basics are harder than the new stuff. Like factoring. And not killing puppies or kittens or seals, which all were killed in your test on Friday. So many seals. It was like a mass murder. It was awesome. Just kidding. It was awful.
Really?
Yeah, it was rough.
Oh.
They're actually mostly graded. I just had 2 people taking it. So probably tomorrow. Hopefully not ruin your day. Some of us need to work on the basics. And so I'm trying to work on that with quadratics today. And one of the basics is factoring. And one of the basics is completing the square. Alright, now I'm actually going to leave this up here. I'm going to dual screen it so we can see this at the same time as we see an example. That's the forward one. You guys see him? There you go. Oh, undo. Poor little Y got stuck. directions are get into standard form. So some of you are going to be like, look at that. I know how to factor him. That's easy. When would you factor him? If you were trying to find the zeros, which is a completely different problem than what you're actually being asked. But if you were to find the zeros, you're right. This is an easy one to factor, and it would be x minus 4 times x minus 3. Do we all see it? So then we have zeros at x equals 3 and 4. That's great and all. But does that tell me the vertex? No. Does that show me the horizontal and vertical translations? Does that tell me where to graph him? All that tells me is the zeros. Now look at this factoring, guys. Is he a perfect square trinomial? No. If he was, what would be true about these two? It'd be the same, right? And they're not the same. He has a 4 and he has a 3. So his factoring was easy, but making him a square, not so much. So, step number 1, get a leading coefficient of 1. Hey, good news, leading coefficient is already 1. Okay, well that step's done. Step 2, form a perfect square by adding. Oh, I have to add something in here? Yes. Y equals x squared minus 7x. Do you guys remember what I did 2 pages back to denote me putting in something? It's a blank, right? Now, the 12 is great and all, but he's not helpful for what I need. The 12 didn't cut it to make a perfect square. So I kind of isolate him and say, you're great and all, I need to keep you in the equation, but you're not good for what I need. Yeah, why is it sad? Next step says, take whatever's left as the coefficient of the x term and cut him in. Bummer, man. That's rough. And then square them. But fractions are our friends as long as we're not too scared of them. We gotta get to know them. Sure, friends not.
Yeah.
So, our next step is we have to form a perfect square. Put something there and something there to make a perfect square. And the way to make a perfect square is say you are half of the original part that forms the perfect square. This is where I'm going. This 7, was double. This 7 was double what was there originally. So I just take the coefficient of the x term, I cut him in half, which is what we did, 7 over 2, and then I square it, and I'm going to add in 49 fourths. Why? Square, square.
Oh.
And what I put in one place, hold on, check the outside like Lucas said. Oh, there's just a 1 out there. So I can keep it the same over here. Does that make sense?
So whatever's out, then when you like time.
Because I need to balance
So
it.
then you put it.
Exactly, but opposite sign.
Okay. But if it had been like 2 or something, then you would have put
Negative.
that combined.
Oh. If it had been 2, I would have multiplied first.
And then put it there.
Got it. And the reason why I did this is so I could get a perfect square. And as long as you follow the steps properly, you have made a perfect square. But now we have to deal with that. Now, 12 minus 49 fourths, that's hard. Don't make your brain work that hard. Who is 12 in fourths? How did I do that real quick? I multiplied by 4 over 4. If I have 12 pizzas and they're all cut into fourths, then 12 times 4, there are 48 fourths. Does that make sense? 48 minus 49 is, oh, that's easy. Negative 1/4.
And that's your answer.
I can see my answer, can you? What would my vertex be if that's what I was trying to find?
7 over negative.
X minus h.
Oh.
K.
Oh, so the vertex is H and K.
Now, can we find the zeros? I suppose if we need them. I boxed the wrong thing.
Yeah, but you're gonna have to square root the minus 7 half.
No, you square root the 49 fourths, which ends up being what was there before you squared it.
Can we do more?
Mm-hmm.
Please.
But did we get one? Did we get one? Did we follow the steps over here?
Yes. Yeah.
Okay. And once we set this all up, did you guys notice where I was able to jump to real fast? Who made the 49/4? 7/2. Why did I put a minus? This term will always be positive. Whether this is negative or positive, squared is a positive. I look on the inside and say, who is your sign? And then that just simplifies down and who's H, who's K done.
Oh, the zeros you got from factoring.
Yeah, that was some factoring.
Okay.
But it didn't help me for the vertex, right?
Yeah.
Now, just a few of you are like, but wasn't there that shortcutty thing if we memorize? Yeah. We could have also said from the very beginning, H is equal to negative B all over 2A. Is that what he ended up being? Okay, there he is. Now wait,
Whoa.
wait. How would you have found K?
F.
F of 8 times.
Then you.
You would have had to do 7 halves squared minus 7 times 7 halves plus 12. How many of you guys are scared of
It's
that?
not that bad.
If you're, oh, no?
Go ahead.
If you're scared of that, maybe you should just do it
Next
this
time.
way.
I'm here.
What if you can't? The whole point is you don't have your calculator. Because if you had a calculator, you could graph it and find the minimum, and that's the first thing. Keep going.
Oh, true.
True.
See?
All right, now what? Oh, we have 2 minutes. Can we finish this one?
Let's get this.
Now, we have a few things left. I'm not saying you can do all of homework, but try to get to as much as you can. Okay? Tomorrow's basically a work day on this with a few worksheets, practicing factoring and practicing, well, a couple of things. What's step number 1?
One.
Be the leading coefficient of, pull out that 3. Who's left?
X squared plus 6x.
3 doesn't go in. It doesn't matter. The 7 we're not keeping
I
anyway.
kind of like that.
Right? Isn't that nice just kind of ignoring it?
Yeah, so that's a deal.
Okay. How do I get that magic number to put in?
Well, we take the inside guy. We say
Take the
half of
inside
it,
guy,
you're
cut
double
him
what
in,
you need to be.
half,
and then
square 'em. So
3 squared is?
9. Well, 3 squared. Yeah, 9.
Wait, why is it? Oh, 3 squared because that's 6.
Yeah. So then I throw a 9 in here, and then I throw a 27 in here.
27.
Wow.
This is
Paris? I
What
don't
was
know.
I thinking when I signed up for this class and not regular pre-cal?
We're going to see this in a couple days in regular anyway.
I think that a couple days.
Actually, it was worth it.
Oh my goodness! We're done! Who's our vertex?
3 and
Oh,
Negative 3,
That's
negative 3.
minus
Negative 3.
H.
Negative 3.
So I not only have my vertex, but I also have my standard form, but I heard a weight somewhere. Wait,
Explain the part where you got 27.
a 9 here, in essence, is a 27 to the whole problem.
Why do you leave the 9 there?
Oh, because that formed my perfect square.
Okay,
And you got 22 from the.
X minus H minus 2. Bye guys, got to get off to do tomorrow. We'll keep on hashing it out. Do as much homework as you can. Don't be discouraged if you can't do it all. It's okay. Bye.
I'm gonna probably have to like drop some acid. Dude, I don't even like.
How do we start from regular?
Put it down, put it in, always an option.
Yes, please.
Always an option. You said just like leave space, but I don't think
I forgot to bring money and food, so whatever people buy, just pay them the money.
you should tell people that.